these are called scatter plots. What does it mean for something to scatter? Spread, run around, all over the place, right? If my thoughts are scattered, they're all over the place. If there's a fight and then it gets broken up, everybody scatters. They get all over the place, everywhere. So scatter plots are just graphs where all my points are scattered. Normally when we see a graph, all my dots are in a nice straight line, right? Or if it was a parabola, it's in a nice curved line. Scatter plots, the dots are just kind of everywhere. Now there's some patterns that we're going to take a look at and notice. But it's a relationship between two variables. An independent variable and a dependent variable. If you're going through a rough patch in your life and you're leaning on your best friend and you say, "Oh, I'm really depending on you right now." What does that mean?
You're dependent.
Yeah, it means you're dependent. What does it mean to be dependent though? Responsible. That's dependable. Very close. Let me put it like this. You depend on your parents to drive you to school in the morning. Most of you.
You're relying on it.
You're relying on it. You need that, right? Whatever, if your mom is running late in the morning, guess what? You're running late in the morning, right? Because you depend on them to get you to school. Does that make sense? Okay? Do you guys know how taxes work? Did you guys hear anything about your parents filing taxes within the last couple months?
Yeah.
Yeah? So what your parents do on their taxes is they claim you as a dependent. What that means is that they are financially responsible for taking care of you because they're your kid. They don't get paid for it, but they get money taken off of their income. So if they make, let's say, you make $50,000 a year, right? And you have to pay 20% of that in taxes. Well, what's 20% of 50,000? Let's see. 50,000 times 20%. So say you're paying $10,000 a year in taxes, right? So really you're only making $40,000 a year. Well, if I have a dependent, I get what's called a child tax credit. What they do is they say, you know what? Maybe you didn't make $50,000 this year. Maybe you only made $40,000 this year, right? It's called a tax break. So parents that have kids, they're financially responsible for keeping that kid alive. The government is like, all right, because you're doing that awesome thing, taking care of that child and making sure they don't die, we're going to take some money off of your income. So now, if I'm only taxed 20% of $40,000 instead of $50,000, now I'm only paying $8,000 in taxes. So you're not getting paid, but you're paying less. Does that make sense? Okay. So when you turn 18 and you start working, your parents are going to start complaining about the fact that they can't claim you as a dependent, which means their income is going to be going up in the eyes of the government. Does that kind of make sense? This has nothing to do with scatter plots, but what I'm saying is you're their dependent, okay? You depend on them for, rides, getting groceries, surviving, having a roof over your head, all that kind of stuff. So a dependent variable is the aspect of the relationship that changes depending on the independent variable. I grew up in a single parent household. It was just my mom and me and my two siblings. My mom was a very independent woman, right? And we depended on her to survive. Does that make sense? So an independent variable is the aspect of the relationship that is being changed. Again, if my mom is running late in the morning, right? That's what's changing. Now all of us children are running late as a result of her running late. Does that make sense? You know what I mean? Now, if we're running late, she's leaving regardless, whether we are ready to go or not when it's time to go, okay? So the difference between independent and dependent variable is one of the what's that? One of them needs the other one. The independent variable changes no matter what. The dependent variable changes as a reaction to how the independent variable changes. That'll make more sense when we look at an example. For example, we've got a table here. What does the X represent? Hours spent studying. That's my independent variable. Hours spent studying. Whatever the x is, that is always my independent variable, which is kind of hard to remember. So when I was learning this and I tried to come up with a way to remember this, the way I always remembered it is if I have an ex, right? If you have an ex-boyfriend, ex-girlfriend, now you're independent. You don't need them anymore, right? They're your ex. So x is independent. Does that make sense? I don't have my, Pookie anymore. We're exes. I'm independent. They're independent. Boom. We're going our separate ways. Okay. So when you think independent variable, automatically your brain should think of the x axis. What's my y-axis here going to represent? Test grade. That's my dependent variable. Now this is a great initial example into this because this is something you guys experience every week or every other week. So we're going to get our test back today. For a lot of you, your test grade depends on how many hours you spend studying, right? So the independent variable is going to change regardless. Some of you studied 0 hours, some of you studied for 10 hours. Your grade on the test changes depending on how many hours you spent studying. Does that make sense? If I studied a bunch of hours, what can I expect to happen to my test grade? It's probably going to increase. If I don't study at all, what's probably going to happen to my test grade? It's going to decrease, okay? Good. So each of these little columns here is one student. This student studied 0 hours and got a 60%. This student studied for only half an hour and got a 65. 1 hour, 70, all the way over to someone who studied for 4 hours and got a 95%. You guys see that? Okay. So each one of these is a student. What we're going to do is we're going to predict, we kind of already did, what relationship these two variables are going to have. So we could say, I predict that the more hours spent studying, the what? Lower or higher grade you're going to earn on the test. What did we predict already?
Higher.
The higher. So again, I'm looking at this graph now. My hours spent studying is my x-axis. My test grade is my y-axis. What you guys are going to take a few moments to do is to plot each one of these points. So I see my hours spent studying, 0.5, 1, 1.5, 2, 2.5, and so on, right? So every little notch on the x-axis is worth how many hours? Every little box is how many hours? Half an hour. And my y-axis starts at 40. I've got a notch and then 50. So what does this first notch got to be? 45. And then 50 and then 55. 60, 65. All the way up. We can fill in those blanks if that helps you kind of visualize what each of these notches is worth. But each little square going up on the y-axis is worth how many, test points? Does it go by ones? 40, 41, 42, 43, 44? No, it's going by what? It's going by fives. Thank you. So this first student studied 0 hours and got a 60. So on my graph, I'm going to go to 0 hours, which is right here. I'm going to go up to 60. And I'm going to make my first dot at 0, 60. Check that one off because I've already plotted it. I'll zoom out so hopefully you can see better. This purple dot right here is 0, 60. Yes? Everybody see how I plotted that? Okay. 0.5 hours yielded a 65%. So now from the origin, I'm going to go to 0.5 and I'm going to go up to 65. Boom. There's my second point. Check that one off. How long did the third student spend studying? 1 hour, and what score do they get? 70. So I'll go over to 1 hour, up to 70, and make a dot. So far this looks like what we normally see, a nice straight line, right? But what's going on with this fourth student? How many hours did they study? 1 hour, and what did they score? 75. So if I plot that point, I go over to 1, I go up to 75, boom. There's my fourth point. Do we have a straight line now? No, we've got something different. So what I want you to do is go through and plot these 6 remaining points on here. We should see a general shape of a line, but it should not be all a nice perfect straight line. Okay, take 60 seconds, plot those last 6 points, and then we'll come together and see how it looks. Alright, looks like most of us got our points plotted, which is great. Fifth student, 1.5 comma 80. Boom, boom. Oops, that's the wrong color. 1.5, 85. Boom, boom. 2 comma 80. Right there. 3 comma 90. All the way up there. 3 comma 70. And 4 comma 95. You guys see kind of the general shape of this graph? Yeah? So in general, as the hours spent studying increases, what's happening to the test grades in this class? They're increasing as well. What about this guy right here? What maybe happened with that dot? Why is it kind of out of the range of all the other points? Rhea, what do you think?
Because it was going higher, but then they put a lower number, which made the dot go down there.
Exactly. So this person studied 3 hours and only scored a 70. That's not really in line with the rest of the class, right? Why might that person have scored so low if they studied for so long, Raya?
He must have got a question.
Hold on one second. I'll come back. Raya?
Maybe they were like unfocused during the test.
Okay, unfocused during the test. That's definitely possible. Raya? Or Rhea. Sorry. Rhea?
He probably got like some answers wrong.
Yeah, he definitely got some answers wrong, but he studied for 3 hours. Why is he getting anything wrong? Because the other dude got 3 hours and scored a 90.
Unless he was messing around.
Oh, he was messing around, so it wasn't like actual studying. He had the book open, but he wasn't reading it too much. Okay, that's a good idea. Eva? Just bad at taking tests, maybe have some test anxiety? Sure. What if the 3 hours they spent studying was from midnight to 3 a.m. and then the test was at 8 a.m.? That's possible. They studied 3 hours, but what happened?
They
weren't complete.
Didn't get enough sleep.
Right.
Right? So this is not an exact science. That's why the points aren't all in a nice straight line, because everyone goes through something different to affect, the relationship between the hours spent studying and the score. But we see in general, for the most part, the more you study, the higher your grade on the test. Okay? That's going to take us to the second piece. Go ahead and glue it in when you get it. I should have taped it on the other side, but it's all right. Once you glue this in, go ahead and answer that first question for me. There's not really any right or wrong answers, it's just what you notice about this. We've kind of already mentioned it, so let's see who's listening, who's not. Okay, one for the front seat, one for the back seat. You just gotta share. Here you go. Who can help me answer this first question? What are some things we notice about this graph that are unlike what we normally see after plotting points on a graph? Yeah, Alyssa.
It doesn't make a straight line.
That's right. No straight line. What else besides not being a straight line? That's the main one, really. But is there anything else that we notice about this that's not normal? Yeah, Eva? It doesn't start at 0. Okay, good. It's definitely not a proportional relationship. It's not a straight line, and it doesn't go through the origin. Very nice. That's going to be all over the SPAC too, so hopefully we didn't forget that. All right. Anything else we notice? I noticed that there's 1 point out of line. Even though it's not a line, it's, a group. There's 1 point out of line. And we already talked about what that student may have gone through in their 3 hours of studying. So unlike linear equations, what does linear mean again? Straight line, right? L-I-N-E, line. So unlike linear equations, these data points are a lot more scattered. That's why we call it, obviously, a scatter plot. Plot means graph, scattered means spread apart. So points that are spread apart across a graph, not in a straight line. So even though it's not linear, it still shows what we call a trend. Everybody say trend. Where have you guys heard trend before, not in the math classroom? TikTok trend. What is a TikTok trend? Something that everybody's doing, right? It's a formula that people are repeating and putting their own spin on it, whether it be a dance, a recipe, an outfit. These are all examples of trends, right? So trend is something that we can see kind of progressing across a large group, right? Not everyone's doing it the same way, but we see that it's kind of, infiltrating the vast majority of people. What are some trends right now that are going on? You said what? Ice bucket challenge? Okay, yeah. People dumping ice on themselves for what reason? Oh, for ALS? That was a thing like when I was in high school, a long time ago.
Oh wait, no, mental health.
Oh, mental health? Okay, yeah. The ALS ice bucket challenge was a long, long time ago. Do you guys remember that?
Yeah.
You were like little kids, probably.
It was like 2000.
Something. It was a long time ago. What's another trend? Like, what's a fashion trend right now amongst the youths?
Crop top.
Crop tops? Okay. Anything else? No? There's no other fashion trends you guys are aware of?
Like.
How about Vans New Schools? There's like everybody wears those. Dunks, yeah, Dunks are a trend. Essentials hoodies, right? We see Beats, yep. We see these like all over the place. Crocs, right? When I was in school, I wore Crocs to school one day, and I got made fun of literally every class I went to because they were like mom shoes or dad shoes.
Yeah.
Of course, Crocs have been around forever.
For real?
Yeah.
I never knew that.
They've only recently been kind of inducted into being like
they
appropriate
changed.
footwear
Yeah.
because athletes started wearing them. Like when I was in school, athletes wore like Nike slides, like the slides with the big swoosh across them, or the Adidas like Velcro wrap over slides. What's up? How's it going? But yeah, nobody wore Crocs. I wore my mom's Crocs. I didn't have Crocs, but my mom had Crocs, which only solidifies the fact that they were mom shoes. But I wore them because I was like, they're comfortable. Nobody's wearing them. I might as well give it a shot. And man, I got flamed so hard. Everybody had something to say. And I did not wear them again. So then when I started teaching, I'm walking around and see all these kids wearing Crocs. I'm like, what? Come on. Like I got basically bullied for wearing Crocs in school. And now everybody's wearing them down till, you can't even. Anyway. But so those are trends, right? So if we're talking about a math trend, we're talking about a pattern that's going on with all these points. You in the wrong class? What do you say? Oh, what class did they send you to?
Miss Karen?
Miss Karan? She has a sub. You should probably just stay here.
Just stay here.
Yeah, she has. Who's your teacher again? Mr. Tao? I'll email him. She has a sub. You should probably just stay here. And then you can sit at the table over there. So, trend, pattern, right? I start seeing everybody wearing Crocs. That's a pattern that I notice. Everybody's wearing, I don't know. We already talked about all the trends. So, the trends in this case is it's going up, right? As the hours spent studying increases, my test grade typically tends to increase. Not in a perfect linear pattern, but enough of a pattern that we can see. And actually, let's go ahead and highlight this little clump here. we can see that it's going up. And not every scatter plot is going to look like this. We'll get to that on the third piece of notes. So, was our prediction correct? We predicted that the more hours you spent studying, the higher your grade on the math test will be. Give me a thumbs up if that was correct. Thumbs down if that was incorrect. Yeah, thank you. It's absolutely correct. We could say that this was correct because most of the points followed the general increase of score as the hours spent studying, or I'll say the hours studied, increased. I'll give you guys a second to write that down, of course. Yeah. After notes. You already missed the first part. I want you to be here for this. So most of the points, like we said, follow this general pattern. But we got one little guy out here that doesn't fall in line with that increased grouping. That point is called an outlier. Everybody say outlier for me. Outlier. It's a point that lies outside of the general trend, right? So when I was in high school and everyone was wearing Nike slides and I had on Crocs, I was an outlier. I was lying outside of what was going on with the trends, right? I also wore like bow ties to school and stuff, so I don't know what I was doing. But anyway,
Both sides with Crocs?
not with the Crocs,
Where do you think
separately. What?
Where do you think it was going?
I don't know, okay? It doesn't matter. We're not talking about how I dressed in high school, even though I brought it up. Outliers.
Both sides.
What?
High school.
Yeah, that's what I'm talking about.
That's weird.
Well, you know,
What would you wear before?
that's what I'm saying. People, I literally just told y'all that I got made fun of for what I wore, and you're sitting here talking about. Never mind. You're making fun of me still. Whatever. I have thicker skin now. It's fine. But you guys get what I'm saying, right? I was lying outside of what the trend was at that time, right? If everyone on TikTok is throwing ice water on each other, and then I get on there and someone pours chocolate milk on me, that's an outlier. It lies outside of the trend. That's a bad example, but you get what I mean, right? So this guy over here, we already talked about what the possibilities are. Maybe they studied too late. Maybe they weren't really doing focused studying. Maybe they have test anxiety. Maybe they were late to the test and didn't get to finish it. There's a bunch of different reasons. So the coordinates of that point were 370. And why might this outlier have occurred? Stayed up too late. Wasn't focused. Test anxiety. What we basically just said. Any questions about that? Okay, let's close it out real quick with this last piece. This is going to be really easy.
Dang!
Dang what?
Why so much notes?
Because a lot of it, I mean, we're just filling in blanks. It's not like we're writing essays or anything. It'll go by quick. The hours will be easy too. I don't know what happened to the top part of this. Christian did not want to work for me, so just try your best to split and read that. Name is AB, right? AB, okay, that's what I thought. Take a moment, glue that in real quick. You take a test? No, just a worksheet. Practice. Is it just a homework assignment? What's up? Pencil? Why do you say you didn't start? No idea. You were just sitting there quiet until. Oh. Oh, I see. Do you have a pencil? Oh. I'm gonna finish this and then I'll email him just to let him know that you're here in case he calls Miss Karan. I don't want him thinking you like, are ditching or anything. So I'll give him an email and I'll try and figure out what it is you need to do. So the top of this third piece, this last piece, that's going to go very quick, says that the association of a scatter plot shows how the two sets of data are related. Right? If you're associated with a certain group of people, that means that you're related to them in some way. So don't worry about this. We're just going to write the word association equals relation. So there are three types of associations that we might run into. We just saw an example of a positive association. And a positive association means that as the independent variable increases, the dependent variable increases as well. So both my variables are going up in relation to each other. The more hours you spend studying, the higher your test grade is. We should see a positively sloping line. If you guys remember, from left to right, we're going uphill. If I draw a little guy on the left side and ask them to walk to the right, are they going up the hill or down the hill? They're going up the hill. You guys remember that? Yeah, when we're talking about slope? Cool. Negative association is the opposite of that. Negative association means I'm going downhill from left to right. Here's my little guy on the left side. If I ask them to walk to the other side of the line, they're going downhill. So this one's the opposite. As the independent variable increases, the dependent variable decreases. A good example of a negative association would be traveling. Anyone ever been on a road trip before with your family? Where'd you guys go on a road trip? LA. Okay, it's like a 6.5 hour drive, right? Where else do we go?
Lake Tahoe.
Lake Tahoe. Okay.
Mexico.
Where?
Mexico.
Mexico, really? In a car? Okay. How long did that take?
This guy has no paper.
Okay, don't say that. You're not very locked in, especially with that Chromebook open. How long did it take you to drive down to Mexico?
47 hours, I believe.
47 hours?
I don't remember.
Sounds pretty long.
I
So,
don't remember.
a negative association is if the x-axis is, let's say, hours driven, and the y-axis is miles remaining, right? Not miles driven, the miles remaining. Let's say you have, 400, LA's like 300 miles away. So let's say you have 300 miles to go before LA. You're going to start your trip right up here, right? You've spent 0 hours driving, but you have 300 miles to go. You guys see that?
Yeah.
As you drive, right, 1 hour, 2 hour, 3 hour, 4 hours, 6 hours, the number of miles left to drive is decreasing. Right? Does that kind of make sense? So it's not a double increase. It's as one increases, the other one is decreasing. Another good example is like working out. The more weeks spent working out, the lower your, weight should get based on, general stuff. So as the time spent working out increases, your weight should be decreasing, right? And the third option is no association. And that just means that there is no relationship between the two variables that we're looking at. It's just one big question mark. The dots aren't all going up. The dots aren't all going down. They're just scattered all over the place. There's no relationship. So an example of two variables that would have no association would be something like, trying to think of a good one that makes sense. Let's say hours spent studying and your height, right? The more you study, do you get taller? No. The more you study, do you get shorter? No. So it's not a positive association. It's not a negative association. There is no association between those two. The amount of time you study has nothing to do with how tall you are, right? So if I went around to all of you and asked, hey, how tall are you and how long did you study for this test, and then plotted all 30 of those points, we're going to see something like this, right? It's just going to be all over the place. There's no relationship between those two things. And that can happen. Everyone cool on association? Quick show of thumbs. How much sense does that make, those three options? Perfect. Awesome. Last thing we're going to talk about is a cluster. Everybody say cluster. Okay, a cluster is just a group of points that are all close together. It's a highly concentrated area of points. I see in this graph, I've got a cluster over here, and I've got a little cluster over there. So this is actually a graph of, do you guys know what a geyser is? Yeah? Yeah, it's like a hole in the ground that shoots up water, I think. Geyser.
Oh, Fortnite.
Are they in Fortnite?
Yeah.
Okay. One of these, you guys ever see these or no? No? Yeah, some of us have. It's in like national parks like Yellowstone and stuff like that. No one has any idea what I'm talking about? Except Leon? Okay.
Yeah, I made them.
Okay. So a geyser, it's like a crack in the earth, and when enough pressure builds up, water just like shoots out every once in a while. So this graph, or this scatter plot here, is how the x-axis is how long it's been since the last eruption, and the y-axis is how long the eruption lasted. So for this particular geyser, most of the time, if it's only been like less than an hour since the last eruption, the eruption only lasts for about 2 minutes. Everybody see that? If it's like a 50 minutes since the last eruption, it's only a 2 minute long, eruption. But the longer it's been since the last eruption, what do we notice happens to my data? The minutes go up, the longer the eruption lasts. So if it's been a long time since the geyser has gone off, when it finally does, it's going to go off for a lot longer. You guys see that? So it's either one of those two. And then we've got this little guy out here. What do we call this point? An outlier. It lies outside of the normal schedule for this geyser's eruptions. So this was one instance where it hadn't been very long at all since the previous eruption, and yet it still lasted 4 minutes, which is fairly long. Could be, a bunch of different reasons for that. I'm not a scientist, so I don't know. But there's an example of clusters and outliers. Pretty easy to tell when there's a cluster. It's just a bunch of points all, crammed together. Yeah?
If you get a question on this, would it ask us if it's an association or not?
Okay, yeah. So if I was looking at this and it asked me for what is the association, what would you say? Positive, negative, or no association? You would think no, right? Because it's kind of all over the place. But because these two clusters are so clearly defined, they show that the longer the interval, the longer the duration. Because in this cluster, it's a longer interval with a much longer duration. So it is technically a positive association going on. Great question. I'm glad you asked that. It will all, for the most part, it'll be pretty clear, right? If I look at these three pictures and told you which one is which, it's pretty obvious which one's positive, which one's negative, which one's no, right? So don't think too deep into it, and we'll stop it there. All right?